Hello! Today I'm going to be talking about balancing developer productivity and security. It's a topic that I think that we don't necessarily think as much on. Usually the balance of developer productivity and security is off. We usually favor one or the other. Developer productivity really measures how fast we can deliver software to production. The more productive you are, the more software that you can deliver, the more features that you can deliver, and the faster your cycle time from the point that you think of the feature to the point that feature is in production. But there's usually a problem. By the time the feature gets to production, there's a security checklist that we've forgotten all about. We have a security checklist that thinks about whether or not we have open network supports. We think about whether or not we've added certificates for encryption. We think about whether or not we've removed development access to production data. This is particularly important if you have an application processing production data and you don't want developers accessing it directly. You also forgot whether or not you should check for vulnerabilities on the host machine that you're running the application on. Applications themselves don't just run on thin air. You have to be able to check whether or not there's vulnerabilities in the code and the machines or containers that they're running on. You have to check whether or not the application has root access, right? Otherwise, if someone has access to the application and manages to exploit it, they might be able to exploit the underlying operating system. So there are a lot of attack vectors that you need to consider, and the security checklist is in place to make sure that you don't violate any of these potential rules. And it ultimately mitigates the blast radius and eventually the attack surface of how someone might exploit your application. This is just a security standpoint. This doesn't even include some of the compliance stuff you might have to have. If you're in, let's say, Europe, you might have to comply with GDPR. If you're in the US, you might have some compliance and regulation on how many approvers you might have for production. The reality is that after this checklist, you realize that 6 weeks later, you're still not in production. The point is you forgot all about these pieces on the checklist, or you just didn't know. And now your developer productivity has been affected. You don't have the feature that you need in development or production for that matter, because you're still trying to figure out why a security or compliance requirement broke your functionality. So how do you balance delivery and security? Well, it's a question that I had to ask myself a lot, especially as an infrastructure engineer and now a developer advocate. I work for HashiCorp, which develops a lot of the infrastructure as code and infrastructure automation tooling today. I'm the author of Essential Infrastructure as Code. And if you would like to get in touch with me, you're welcome to find me at these handles as well as the website below. And most of what I focus on is how do you balance getting the delivery pace to match the kind of security stance that you want to have in your organization. It's a really difficult balance, but I discovered that there's actually a bigger problem, and it's not about security, and it's not really actually about developer productivity either. It's about education. Think of it this way. We address the known knowns about our applications and systems using testing. So we test for things that we know and we expect to find. So for example, if my feature or if my system should have this functionality, I know to test for it. We also test for known unknowns. Known unknowns is what usually people focus on for monitoring. So if our CPU increases, well, we want to at least know what's happening, right? It's unknown until we actually go and we find out what's happening and what the information we need. So that's what monitoring is supposed to cover. These days, we also have observability, which is focusing on the unknown unknowns. Observability allows you to examine something you don't know and make sure that you get the information that you need. So you might not know what you're looking for, but at least you have the information that you can find. Then there's this unknown category of unknown knowns. And I know it's a little complicated, so bear with me, but unknown knowns are what I think about as security and policy. It's something that someone else knows, right? It's siloed knowledge. And this is where our problem resides. Most of security and policy are unknown knowns. And the problem is an education problem. We need to be able to teach the unknown knowns across the organization. And that's why developer productivity and security are imbalanced at times. It's because as developers or engineers, we may not know what we don't know about security, and we need to learn a little bit more about it. So how do we solve this problem? Well, one solution is to use something called policy as code. Policy as code is the management of an organization's policies with code to ensure the conformance of changes. So if you can imagine this process, the idea is that you want to first check if a change conforms to our organization's policies. This is a little bit counterintuitive, right? Because most of the time, as a developer or engineer, you're building some functionality, pushing it to production, and then you check whether or not it's conformed to some policy or some security. So what this is saying is let's move this as a first step, which is let's check if the change actually conforms first before we actually push the change. And once we push the change to production, we can have a second subset of things that checks if the environment conforms to our organization's policies. The latter half of this flow usually focuses on reporting and auditing. So if the environment does not conform, then we take remedial action. But policy as code describes both ends, right? It describes the first half of it, which is let's check if it first conforms, if the configuration or change that we're making even conforms to anything that we're looking for our organization. And then we can check whether or not the environment itself needs to be remediated for anything. The thing is, policy as code is just one term that refers to this. In the time that I've spent working in this space, I found out a lot of people use different terms for this. So you'll also hear shift left security testing. It's borrowing from the approach of general shift left testing, which is to test the configuration before production. Similarly, in this case of security testing, you're testing for secure configuration or compliant configuration before production. There's also fitness functions for architectural conformance. This is along the lines of evolutionary architecture. I won't go too much into it today, but the idea is that fitness functions measure how far away you are from architectural conformance. In this case, we're talking about security conformance. There's also this idea of static and dynamic analysis for security. Most tools in the security space separate themselves as static analysis or dynamic analysis. Similarly, policy as code is actually both, because what you're doing is configuring the rules for these static and dynamic analysis tools using an infrastructure as code approach. As the author of infrastructure as code, if you're curious to learn more, you're welcome to ask me more about what infrastructure as code specifically is. But the idea is that since you're a static and dynamic analysis tooling is part of your system, you should treat it as extended infrastructure, and thus you should configure the rules with an as code approach. The other important part about dynamic analysis specifically is that it's focusing on continuous verification or remediation. And that counts. You need to be able to specify the rules and version the rules you want for verification and remediation. So for example, if you maybe loosen a remediation rule, right, saying we don't want to have anything in our running environment to have root access, you might want to adjust that rule. And in that case, you should probably do that as an as code approach so that you can communicate to someone else and teach someone the rules that you do expect for remediation as well. All right, so let's try it. I'm going to actually do one example of how you would treat policy as code. Let's say I'm an engineer and I want to update a network policy rule. This network policy rule should allow all traffic to all ports from 172.16.0.0/16. If I update this policy rule, I am basically opening traffic from 172.16.0.0 to all ports. So there's something that I need to think about. Do I want to do that? Should I do that? And actually, my organizational policy tells me, hey, we don't really want you to do that. My organizational policy is no network policy should allow traffic to all ports. Basically, the security team wants you to be really specific about which ports the traffic should access. So in this case, if I try to make this change and I check if the rule conforms to the organization's policies, I actually should fail, right? So this should flag it as a problem right off the bat. And that way I can go back, fix it, and then eventually make the change, push it to production. And from a remediation standpoint, which is the second half, the more dynamic analysis part of this, I don't necessarily have to check if the network policy configuration conforms to the organization's policies, as much as just someone maybe manually going in and updating the rule, and then maybe there's remedial action that needs to be taken. But both sides will effectively be addressed by this one policy. and it will check the same kind of change. All right, so before I go into the actual code base, what I do want to state is that most policy as code tooling uses pretty much one mechanism. Policy as code tooling grabs the state of a system. Usually the state of the system comes from an API, from the infrastructure runtime. It could come from the application. There's a lot of different places that you can grab state, but state is usually expressed in the form of JSON or metadata format. So that JSON or metadata format is parsable. The result is that most tools first parse for certain fields, and then they check the field values for whether or not they conform to some test policies that they have, and the tests pass or fail. The reality is you can implement your own policy as code tooling. That is what I'm doing today, but the focus, at least for parsing through some of these fields and the abstraction, is that it makes it easier if you have a pre-existing tool that parses for the right fields, right? So most tools are just going to make it really easy for you to parse the right fields that you're looking for, rather than you looking at the JSON and trying to figure out the right schema that you need to get to. All right, so let me switch the demo. All right, in this demo, I have a setup for the network infrastructure rule. The network infrastructure rule is an AWS security group for those who are more or less familiar with Amazon and infrastructure and cloud providers. This Amazon security group rule is basically the configuration I plan on pushing to production. Notice I have the CIDR block of 172.16.0.0, and I have decided I'm going to open my ports from -1 to port -1. In AWS security group, the API uses -1 to denote all ports. So I have my policy check here. I've already written this policy as code. The policy as code is trying to be as expressive as possible. As a general rule, I try to make sure that if someone is reading this who doesn't know any better, they would be able to understand what's going on. Again, communicating the unknown knowns to someone else. So in this case, I have a network policy check that says policy should not allow traffic to all ports, change to range or specific port. So there's two parts to making sure you write good policy as code. The first is make sure you're clear on what the policy is. The second is change to range or specific port, which is the action. Like, how do I take action to fix this problem? So in this case, I read in the configuration for the AWS security group, and then I'll parse through some of the attributes. And what my test will do is test that no network policy should allow traffic to all ports. What this is doing is it's going to check the to port field and the from port field for this -1, which means it shouldn't have all ports. If I run this test, I expect it to fail, right? Because this policy is saying that I should not have all open ports. And it's actually what it refers to, right? So it prints out the policy should not allow traffic to all ports and then change to range or specific port. This is really important. It tells me that this has failed. So as someone who's an infrastructure engineer or developer who's doing this, what I'm going to realize is, oh, I didn't pass this policy. This is a problem. Let me go in and let me change my configuration. So I'm going in, I'll change my configuration to 5432 because this is my, let's say, it's PostgreSQL or something. It's a database port. So I'm going to be really specific. And let me run the test again. When I run the test again, the policy passes. It means that I can actually push this to production. I can add this to a continuous delivery pipeline. I can add it to any automation I have that verifies tests or checks for information before going to production. My approvers are able to see that these tests have passed. My security team has some peace of mind because they know that it's secure and this is checking before it goes to production. So this is where the power of policies code helps communicate these changes, right? I don't necessarily have to go to a huge document and figure out what policies I should have in my infrastructure and how. Instead, I'm able to use the policies expressed as code, run them against my configuration, and ensure that it's compliant from the very start. So in summary, the focus is to use policy as code to drive secure developer productivity. Rather than make this narrative about balancing developer productivity and security or having one or the other, drive secure developer productivity from the very start. The idea is that if you can bake security into your development process, it makes it easier for you to scale your security knowledge across your organization, and even compliance knowledge too. Some general helpful practices I recommend when you start doing policy as code. Version control. If you're familiar with infrastructure as code, the practices are very similar. You want to version control all of the policies that you have. That way you can refer to any changes that have been made, and you can always revert changes to policy as well. Make sure your policy is descriptive. As I mentioned before, someone should be able to understand the type of policy and how they can take more actionable behavior to remediate it. On top of that, you can identify mandatory versus advisory. Not all policies are mandatory. There's a nuance to this in that you may not want every vulnerability scan to fail if the output is always high, right? So if there are high vulnerabilities or high CVEs in a container image or a virtual machine image, well, does that mean that it should always fail? And the answer is not always. You have to identify which policies are more mandatory in nature and which ones are more advisory. In addition, manage policies as libraries. I recommend bundling the policies together and sharing them across your organization as libraries, making sure people can iterate on them. And make compliance and security accessible. It's okay to keep these policies in some ways open, right? You want people to understand the kinds of security posture that you expect them to adhere to, especially from a development standpoint. So even if it means from a compliance standpoint, you expect code quality to be a certain percentage, add that to delivery pipelines for applications so that it is accessible for someone to be able to test and recognize when they have a problem. If you're curious to learn more, you can always check out this GitHub repository that I have. It has some more policy as code examples. You can also check out this video from OWASP DevSlop about testing security and shifting it left. And if you want to learn more and have greater detail about how this fits into infrastructure as code, there is a policy as code section in my book. And you can find these slides at my personal website below. So if you're curious to learn more, definitely reach out to me, and I appreciate you tuning in today.